Dear students, I am Dr. Tamrakar from Bharati College of Engineering and Technology. I am teaching fluid machinery in BE 5th semester. Today we will solve one numerical. A reaction turbine works at 450 rpm under a head of 120 meter. Its diameter at inlet is 120 centimeter. Flow area is 0.4 meter square. The angles made by absolute and relative velocities at inlet are 20 degree and 60 degree respectively with the tangential velocity. Determine first the volume flow rate, second the power developed, and third hydraulic efficiency. Assume work at outlet to be 0. This question is very important and many times it is asked in examination. Here the data given n equal to 450 rpm, head h equal to 120 meter, diameter at inlet B1 is given 120 centimeter, that is 1.2 meter. Always care about these units. Sometimes it is given in millimeter and this time it is given as centimeter. So flow area is given, flow area that is equal to pi d1 b1 is given 0.4 meter square. Angle made by absolute velocity at inlet alpha equal to 20 degree and angle made by relative velocity at inlet, that is theta equal to 60 degree. One at outlet VW2 equal to 0. Tangential velocity of turbine at inlet U1 equal to pi d1 n by 60. Putting the values here, pi into 1.2 into 450 by 60. So this comes 28.27 meter per second, and from inlet velocity angle tan alpha equal to Vf1 by Vw1. Here alpha, tan alpha equal to Vf1 by Vw1. This is tan alpha, and putting the values here, that is tan 20 equal to Vf1 or by Vw1 that is equal to 0.364. So Vf1 equal to 0.364 Vw1. Then theta equal to tan theta equal to Vf1 by Vw1 minus U1. This is 0.364 Vw1 by Vw1 minus 28.27, and this tan theta is tan 60. So here the value of tan 60 is 1.732 equal to, this is 0.364 Vw1 by Vw1 minus 28.27. Here we can calculate the value of Vw1 equal to 35.79 meter per second, and putting the values in above equation, we will find Vf1 equal to 0.364 into 35.79. So this is 13.027 meter per second. Now we have to calculate volume flow rate from here. This is volume flow rate by d1 v1 equal to 0.4 meter square. And as we know, Q equal to pi d1 v1 vf1. So here putting the values of pi d1 v1, that is 0.4 into value of vf1 13.027. So the value of Q comes 5.211 meter cube per second. This is the value of volume of flow rate Q. Next we have to calculate work done, that is rho Q V W1 U1 when VW2 equal to 0. Here been given. So putting the values here, rho is 1000 for water, Q we have calculated 5.211, VW1 is 35.79 into U1 is 28.27. So the value of work done is 5272402 Newton meter per second. And for getting the power, if we divide this by 1000, then this is also watt. So we can find this 5272.402 kilowatt. Now we have to find the efficiency, hydraulic efficiency equal to V W1 U1 by G H. Potential values 35.79 to 28.27 by 9.81 into 120. So this is 0.8595, that is 85.95%. So this question is asked in examination number of times. So this is better you solve this type of questions, and we will solve more questions on this topic. Thank you. Next, we will take one more numerical. As inward fluid injection turbine has external and internal diameter as 1.0 meter and 0.6 meter respectively, the hydraulic efficiency of turbine is 90% when the head of the turbine is 36 meters. The velocity of fluid outlet is 2.5 meter per second and discharge at outlet is radial. If the vane angle at outlet is 15 degrees and width of wheel is 100 mm at inlet and outlet, determine first the guide blade angle, second speed of turbine, third vane angle of funnel at inlet, fourth volume flow rate of turbine, and fifth power developed. Here the data given D1 equal to 1 meter, T2 internal diameter D2 is given 0.6 meter. Hydraulic efficiency is given 90%, 0.9. Head is given 36 meter. Velocity of fluid outlet we have to 2.5 meter per second. Discharge is radial, that means VW2 equal to 0. When angular outlet 5 is given 15 degree. Width of wheel is given B1 equal to B2 equal to 100 mm, 100 mm, that is equal to 0.1 meter. Sometimes someone is confused with 100 mm. He may think 100 centimeter and he will convert this into 1 meter, but this is given in mm. Okay, so take care. Using the equation eta hydraulic equal to V W1 U1 by G H, that is given 0.9 equal to V W1 U1 by 9.81 into 36, then value of VW1 U1 comes 317.85. Now from the outer rectangle, then phi equal to VF2 by U2 equal to 1015, that is 1015 equal to VF2 is given 2.5 by U2 putting the value of 1015 here. Here U2 equal to 2.5 by 1015. Is equal to 9.3333. Here, as we know, U2 equal to pi d2 n by 60 by 60. So this is 9.33. Pi into d2 is 0.6 n by 60. So here the value of n comes to 96.98. Now similarly you have to calculate U1 for this n, that is pi d1 n by 60. Pi d1 is given 1 meter, n is 296.98 and 60. So the value of U1 comes 15.55 meter per second. Substituting of this value of U1 in equation VW1 into, that is 15.55 U1 equal to 317.85. So here the value of VW1 comes to 20.44 meter per second. Now, as you know from the continuity equation, pi d1 df1 equal to pi d2 v2 vf2, and this is q. So here d1 vf1 is equal to d2 vf2, putting the values here vf1 equal to d2 vf2 by d1, that is equal to 0.6, 2.5 by 1. So this comes 1.5 meter per second. Now we have to calculate the guide bed angle. Del alpha equal to Vf1 by Vw1, so that is 1.5 by 20.44, that comes 0.07338. So here alpha equal to 4.19 degree or 4 degree 11.8 minutes. Okay, this is the value of alpha. Now the speed of turbine is 2. The speed of turbine we have calculated earlier, 296.98 RPM. Then angle of runner at inlet theta, that is tan theta equal to Vf1 by Vw1 minus u1. Putting the values here, 1.5 by 20.44 minus 15.55, that comes value of theta comes 17.05 degree or 17 degree 3 minutes. Now we have to calculate the volume flow rate of turbine. This is equal to pi d1 v1 vf1. Putting the values here, pi into 1 into 0.1 is v1 into 1.5. So this comes 0.4712 meter cube per second. And next is power developed. Power developed equal to work done per second by 1000, that is rho cube Vw1 u1 by 1000. When output is radial, that is Vw2 equal to 0. Putting the values here, rho is 1000 for water, Q we have calculated 0.4712 into 20.44 into 15.55 by 1000. This is both, so we find the 149.76 kilowatt is the power of this turbine. So you have to solve more and more numericals for getting expertise. Thank you.